I was like, I thought that was
No, I got it.
Oh, yeah. Actually, they're pretty good. They'll come back around.
Oh, right.
Okay, before we go over the exam, I just want to do one problem that we almost did last week. Okay? If you recall, the last topic that we covered on this was Wednesday was substitutions. And I said this is very analogous to what you had with calculus. Many times you have these integrals, and they usually come under a category called miscellaneous substitutions. And it's not like a trig substitution creation by parts. It's where you see in the integrand some integral that some expression occurs, once or twice, and it makes sense to make a substitution like that. And the general equation that we looked at, and I showed you that it always becomes separable, is what we saw is that dy dx was an arbitrary function of ax plus by plus c. Okay, well, this is any arbitrary function, right? General, right? It could be the sine of this or the cube, whatever, okay? Then the substitution to make was let u equal ax plus by plus c. And what I showed is that in general, when you make that substitution, the equation becomes separable. So here's a specific example, okay? So we've got dy dx. Now our function is just y minus 2x. Okay, in this case it's the square of that. Okay, could have been anything. Okay, so the differential equation is dy dx is y minus 2x squared minus 7. And let's make an initial value problem. Y of 0 is equal to 0. Okay, so let's get the general solution to that. So following the fact that we have a function of y minus 2x, I'm going to let u equal y minus 2x. Right? That makes sense. And then if I differentiate, I get straightforward du dx is what? dy dx minus 2. Right? Now I'm going to change the dependent variable equation from y to u. So on the left-hand side here we have dy dx. We'll replace that by du dx plus 2. Right? That's your dy dx, du dx plus 2. And then the y minus 2x quantity squared becomes u squared minus 7. And clearly that's equivalent to du dx is equal to u squared minus 9. Right? And you can see, obviously, it's separable, right? We get the integral du over u squared minus 9 equals, on the other side, it's x plus arbitrary constant. Okay? And how do we do that one? Okay, we know first get the roots and use partial fractions. Okay, so let's do that. Okay, the 1 over u squared minus 9, of course, is just 1 over u minus 3 parentheses u plus 3. That's to get the roots, right? And we know that we can do a partial fraction expansion by some coefficient, let's call it a1 over u minus 3, plus another coefficient a2 over u plus 3. And you have several ways of getting a1 and a2, whichever method you prefer. You can multiply both sides by u squared minus 9 and match coefficients. Or another way you can do it is just multiply, to get a1, for example, multiply both sides by u minus 3, and then take the limit as u goes to 3. So we have a1 then is the limit as u approaches 3. I'm multiplying by u minus 3, so I get 1 over u plus 3. Clearly that's positive 1/6. Okay? And then what about the a sub 2? To get a sub 2, I'm going to multiply by u plus 3, and then let u go to negative 3. So that'll go to 0. So that's just the limit as u approaches negative 3. Multiplied by u plus 3, 1 over u minus 3, and clearly that's minus 1/6. Okay? So, 1 over u squared minus 9 can be therefore rewritten as a1, what do I find for that? 1/6 times 1 over u minus 3, right? So a1 plus a sub 2, which is minus 1/6 times 1 over u plus 3. Now we know that when we take the integral of this, the antiderivative, it's going to be logs. And the question is, you don't want a log of a negative, okay? So when we basically don't have an initial condition, we kind of just make it log u minus 3 and it really doesn't make much of a difference. But let's see what's going to happen over here. we know that when x equals 0, y is equal to 0. Okay, x equals 0, y equals 0. So I come up over here, well, we'll plug in x equals to 0, y equals 0, u is equal to 0. So what this really says is that at x equal to 0, u is equal to 0. Okay? Because when x is 0, y is 0, that's u is equal to 0. So you see over here, if I basically make this a log of u minus 3, then I plug in u equals to 0, I get a log of a negative. I don't want to have that. So I'm just going to switch the sign on that. Okay? So I'm going to say 1 over u squared minus 9. Just pull out a minus 1/6, right? And that's going to be 1 over 3 minus u. Okay? So when I integrate that and I get a log, I'm okay at 0. In this case, obviously, is no problem, 1 over 3 plus u. Okay. So let's go back over here now. Okay? And we'll integrate. Okay? Well, the integral of 1 over u squared minus 9, that'll be 1/6, right? When we integrate this, be careful, you get the minus the log of 3 minus u, right? Because if you use the chain rule, you get a 1 over 3 minus u, and you have to differentiate 3 minus u with respect to u, which you know the minus sign. Okay? Plus the log plus the natural log of 3 plus u equals x plus arbitrary constant. Okay, let's multiply through by 6 and use our log rules. So that becomes a natural log of 3 plus u over 3 minus u. Right? That equals 6x plus, let's just call that 6c1, c2. Okay. Now we can get the initial condition, right? When x equals 0, u is equal to 0. So what happens over here? Okay, remember, x equals 0, u equals 0. So plugging in on the left, u equals 0, I get the log of 3 over 3, which is log of 1, which is 0. That equals 6 times 0 plus c2. Therefore, c2 has to equal 0. Okay? So now we have the natural log of 3 plus u over 3 minus u is equal to 6x. Right? And then again, we want to solve for u ultimately because I want to solve for y in terms of x. So let's first try to solve for u. Well, we want to get rid of that log, so you get 3 plus u over 3 minus u equals the exponential of 6x. Okay? Let's cross multiply. I get 3 plus u equals 3 times the exponential of 6x minus u exponential of 6x. Okay. Yeah. Let's bring the u stuff to the left. I got u 1 plus exponential of 6x. Right? U plus 3 6x. And bring the 3 to the other side. I got 3 paren e to 6x take away 1. Finally, we get u. That becomes 3 parentheses e to the 6x take away 1 divided by e to 6x plus 1. Okay, and we're almost there. But what's u? U is y minus 2x, so I'll substitute for u y minus 2x, bring the 2x to the other side. We find that y equals 2x plus 3, parentheses, e to the 6x minus 1, divided by e to the 6x plus 1. Let me just check that. Okay. So, any questions about that? It's just a simple, substitution. Okay, so let's go now and go over the exam. Okay, like I said in the email, I'm going to be very careful to show exactly how I graded it. Okay, and again, please don't come up to me and say, "Oh, why did I only get 3 points on this? I think I should have gotten 5." I was very liberal in grading. Okay, and also, what I want you to understand over here is that this should also be a learning experience. Okay, I'm going to now, as I go over them, this is fresh in my mind, go over some common errors that people made. Okay, some of them I anticipated. Okay, so a lot of people don't. It is half the people don't come to class, so maybe they missed it or something. Okay, so here's another opportunity. Okay? And again, the most important thing is the technique that you follow on these things, not so much the answer. Okay, as long as it makes sense to me, I try to be very liberal with the credit. Okay. Let's see, I'm gonna do this in alphabetical order, probably the easiest. Okay, so just pay attention. And again, excuse me if I mispronounce names. Okay. Okay, so first, Abdul Raham Ahmad. Okay. Then there's Abdul Raham Jassim. Okay. Alajmi Abdul Aziz. Okay, they just, yeah, when I call your name, just come up and take the exam. This is you. Okay, Al-Amir Hussein. Okay, this one is tough. AIAMRI. Ali Khalid Talib. Okay. Is this you?
Yeah.
Okay. ALDIGHAITHR. Okay. Aljadi. ALJADI. ALJINA. Okay. Alkandri, ALKANDIRI.